So in this video, we're going to be talking about gradient and position time graphs. And this video is a continuation of our first video on gradient and position time graphs. So if you haven't seen that video already, go ahead and watch it first. In this video, what you're going to do is you are going to watch a second example of how these graphs are constructed. And by the end of this video, you will hopefully be able to use position time graphs to construct velocity time graphs. So let's go ahead and do one more example, because I know this is a pretty challenging skill for a lot of people. So what I'm going to do is I'm going to give you this position time graph, and again, I'm going to go ahead and I'm going to split my graph up into all of the flat line sections that I can. So here I've got a lot more slopes defined. So I've got slope number 1, slope number 2, slope number 3, slope number 4, and slope number 5. So I'm going to start with slope number 1. And so I've got my first velocity, and that is going to be equal to rise over run. So we've got our first point and our last point at 0, 0, and at 2, 2. So it's going to be 2 minus 0 over 2 minus 0, or 1 meter per second. So our velocity here is going to be 1 meter per second. Let's go ahead and do the same for number 2. So we've got our start point and our end point. We're starting at 2, 2, and we're going to end at 4, 2. So my x value is 4, that is my time is 4, and my y value, my position, is 2 meters. So V2 is going to equal my second y value, so my second position, which is 2, minus my first position, which is also 2. And that's going to be divided by my second time, which is 4, minus my first time, which is still 2 seconds. So what that'll give me is 0 over 2, or 0 meters per second. And you can tell as well from the graph, right? So we're staying in the same position for seconds 2 through 4. And so what that means is that you're not moving, right? So your velocity has to be 0. So now let's look at our third section. So we're going to start at 4, 2, and we're going to end down here at 6, negative 2. And we can put that again in our graph for V3. So we're going to have our negative 2 minus 2. So our final position minus our initial position. And we're going to divide that by our final time of 6 minus our initial time of 4, which is going to give me negative 4 over 2, or negative 2 meters per second. And that negative is exactly what we expect, right? Since we're going downhill in section 3. Section 4 is flat, just like section 2. And you should recognize that any time you have a horizontal line like this, your velocity is going to be 0 meters per second. And again, we know that because we're not moving. We're staying in the same position. And the graph is just representing that with a flat line. And we have our very last section, which is going to be section 5. We're going to be starting at 7 seconds and negative 2 meters. And we're ending at 8 seconds and 1 meter. So let me go ahead and figure out that velocity. So we're going to say our final position of 1 minus our initial position, which is negative 2. And we're going to divide that by our final time, 8, minus our initial time, 7. So what that's going to give me is a velocity of 3 meters per second. And again, it's the sign I expect because, again, I am going uphill. So now I am ready to construct my graph. So what I've done is I have created my time versus velocity table, and I have constructed my graph by writing out my axis labels, my scales, and my title. So I am ready to graph. And before I do that, one last thing, I've also helpfully color-coded here where my sections are. So my first section, second section, third section, fourth section, and fifth section. And so now I'm ready to draw. And this time, I'm actually going to skip the part where I add in points. So for seconds 0 to 2, I know that I am traveling at 1 meter per second. So that's going to just be a nice straight line. And then at that point, I immediately am going to flip I'm going to stop walking immediately at 2 seconds. So after those first 2 seconds are completed. And for seconds, the third second here and the fourth second, I am going to be traveling at 0 meters per second. And then again, I'm going to immediately start moving again, and I'm going to move backwards. So for seconds 5 and 6, I am moving at -2 meters per second. So I'm going to go all the way down to -2 for my 5th and 6th seconds. Then for my 7th second, I am standing still again. So I'm going to go ahead and draw that standing still. And my very last 8th second, I'm going to go all the way up to 3 meters per second, because that is my speed for that last second. So one thing I would like to point out here, guys, when you think about each second, don't think about where the number is on the graph. Think about the space between the two lines. So that is my first second. This is my second second. So we can even ignore that 0th second. My third second, of course, is this part, which is why we have this vertical line here. So for those of you who are maybe a little confused about the vertical lines part of this drawing, hopefully that clarifies things a little bit. So let's go ahead and talk about takeaways. So first of all, to go from a position time graph to a velocity time graph, so position to velocity, you need to find the slope of the graph. Second, breaking apart your graph into sections that are straight lines is a good strategy for figuring out your slopes and therefore your velocities. So go ahead and see if you can do this on your own. Try your very best, solve some problems. Best of luck and happy solving.